Okay, welcome everybody. My name is James Kress. I'm from the KAUST Visualization Core Lab, and I'm going to be presenting today on Scientific Visualization 101 with VisIt. So this is going to be mainly a hands-on tutorial. So we're going to focus on getting into VisIt, learning what scientific visualization is, seeing some of the basic things VisIt can do, and we'll go from there. So we'll get to what we get to in our 2 hours today. There's maybe other stuff in the slides we don't get to, but you can always check that out on your own time or email us and we can set up a time to chat. So as you can see over here on the right, for those of you in the room, we are live streaming this. This is our live stream view. So just so that you're aware, we've got an audience online. The only camera that we have recording is the one from the very back pointing right here. So if you don't scream, you won't be on the audio. Nobody will hear you, nobody will see you. So no worries there. So I guess we'll jump right into it. So if you have questions throughout, let me know. We're going to do a quick introduction, and then we'll take a short break to download VisIt, download the data files, and get things running. So to start off, a little bit of contact information. So you can check us out on our wiki. So the KVL has a wiki. You can check us out. We have a bunch of different FAQs, information on peer review, VisIt, Aviso, other stuff that we offer in the Visualization Core Lab. And you can find that there. If you have any general questions, want to set up a collaboration with us, you can email us at our help@vis.kaust.edu.sa email address. We'll answer those and answer questions through that avenue. And on the right over here, we have different VisIt user resources that you can download or you can check out if you want to ask questions about VisIt. Go to their wiki, go to their user forums, and that sort of thing. One thing that we like to do at the start of these introduction workshops, at least, is to discuss Visualization Core Lab in general, just so you get an idea of who we are in case you're new to KAUST, or if you've never used our services before. There are people here that have been here for years who sometimes don't know who we are and what we offer. So we are a 6-person team. We have our team lead. He's sitting up here for a few minutes to make sure that we get off to a good start. And we all have different expertise. So his expertise is information visualization. Tom is another member. He's up here in this corner. We are both on scientific visualization. So he's an expert in peer review. He's an expert in the math and complexities behind visualization. So if that's your kind of question, see him. He's very good at that sort of stuff. I focus on HPC visualization, so using Shaheen, using Ibex, using clusters, doing visualization on and off of those, and then also doing in situ visualization. So doing visualization during the course of an active simulation. And we have an AR/VR person, Ronell, and then we have 2 data scientists, Didier and Abdelfor, and so they can help you out with data science questions, machine learning, deep learning, AI, that sort of thing. So we have 3 primary tenets in the Visualization Core Lab. One, we have facilities that we can offer out for different uses around campus. That's one of our functions. Another function, of course, is training and workshops. You're in one of those today, and we have a bunch more coming up this term. And as well as our YouTube channel, we have lots of past videos on there. You can check out interesting stuff. And finally, the most important one and the one that we do the most work in is our data visualization, data science workflows, and collaborations, and that sort of thing. So we have a number of different workflows that we already have set up for around campus for peer review, VisIt, Aviso, image segmentation, and that kind of thing that we can help you set up and get you going on. But also if you have a research problem, you don't know how to start, you don't know where to go, we can help you with that as long as it's visualization, data science related, that kind of thing. And so we're open for these collaborations and we'd love to hear from you. And so talking about our facilities, these are the primary facilities that we offer. We have HMDs, segmentation tablets, and then Cube's VR facilities. This is a semi-immersive VR curved wall. And then we have 2 planar display walls called Zone 1 and Zone 2. And so I'll show you a little more of Zone 2 right now. And so the main idea behind Zone 2 is for doing visualization and collaboration. We have peer review and VisIt that can both run on that wall. You can connect to network storage, Ibex, Shaheen, that sort of thing, and do your visualizations on the large wall. And then we also have Sage 3 collaboration boards, which is what we use to display those images down there. So you can actually get a bunch of people connected. You can drag and drop images, data, and collaborate that way. And then if you'd like to reserve these facilities, you can book through our wiki. It requires your portal credentials. Log in, you can create a booking, or if you have questions about what a good use of our facilities might be, send us an email at the help line, and we can tell you if your idea is a good use for the facilities and what we can help you do. And talk about upcoming training. Like I said, we have a bunch. So this is the first one for this term. We have more in the scientific visualization workshop series. We have a data science workshop series, hands-on AI tools and techniques series, as well as a data science on Ibex and Shaheen. All of these are coming up this term, so we've got a lot of stuff coming up. Check those out if you're interested in any of those. So for today, what's the goal of today? So like I said, today's goal is hands-on learning with VisIt. And so prefacing this is an introductory course. So if you haven't done scientific visualization before, haven't used VisIt before, this course should be for you. So we're going to start slow. We're going to start with installing. We're going to get data. We're going to start looking at data and do a little bit of explanation of what scientific visualization is. And why do you care about VisIt at KAUST? Well, it's an open source scalable tool. So that's one good reason. We can all contribute to it. Another good reason is it's available on all of our major computational resources here at KAUST. We have this running on Ibex and Shaheen, and you can connect right up to Ibex and Shaheen and load your data and do your visualizations without transferring any of that data back to your local computer. And finally, of course, VisIt we have on the KVL tile display walls. So now I'm going to jump into a little bit of VisIt basics. That's a little bit of an overview of KVL. I'll do some VisIt basics. And then we'll have a break here in a minute to download VisIt and download our data files. So what is VisIt? I'm going to move back behind here now, so I have to stop looking over my shoulder. So what is VisIt? This is an open source turnkey application for mesh-based data. And so that's one good thing to take note here. Most scientific data that we work with has some sort of underlying mesh, some way that the data is connected, some way to know how the different elements fit together. And VisIt also has an infrastructure for parallel post-processing, so this is very important when we start working on Shaheen. You can run on thousands of nodes of Shaheen and visualize very large data that way. So you can take advantage of all of the different memory capacity of the full Shaheen. And finally, it has built-in in-situ capabilities. So what are some great use cases of VisIt? So you can do data exploration, comparative analysis, quantitative analysis, visual debugging, or even presentation graphics. It's a very wide purpose tool once you start getting to use it. So what are some of the different plot types? So a lot of the stuff we generally do are streamlines, pathlines, pseudo-color rendering. If you've used ParaView before, that's similar to the surface plots in ParaView. You have molecular visualization, parallel coordinates, and volume rendering. So how do you obtain VisIt? This is something hopefully you did before the workshop, or we'll do it here in a minute. Download it for your laptop or your workstation. All these binaries are available on the VisIt release website. And we, as the KVL team, we manage our builds on Ibex and Shaheen. So we have those available and ready to go for you. And finally, if you want to get really into it, you can build VisIt yourself. And so if you have others, if you want to extend VisIt or do something within the VisIt source code, that's easily possible. All right, so how do you get your data into VisIt? So VisIt has over 110 different file formats. So there's a lot of different ways to get your data into VisIt: VTK, Silo, XDMF, BVTK, just to name a few. And then there's also a plain text reader. If you want to just input CSVs, you can input CSVs and get your data in there that way. There's also ways that you can write VTK files from your simulation code. The VisIt can easily write or easily read. And if you have a conduit, so conduit is a technology from Lawrence Livermore National Lab in the United States. And so they have, it's a way of representing data, and so there's support for mesh-based conduit interaction as well. All right, so some visualization techniques. So these are a few of the things that we'll talk about today. So as I said, pseudo-color rendering. If you don't know what this is mapping scalar fields to a range of colors. So if you think of this in 2D over here, it's easy to see on a map. So you're mapping scalar fields to a range of colors. So you can think of this as representing height. So if you're at sea level, it's blue in the ocean, or if you're at sea level on land, it's green. And so that's just mapping color value to the scalar values in your data and then displaying that. On the right over here, there's a pseudo-color rendering of density. This is density from a simulation. And you are seeing how dense the simulation is as it progresses. Next, volume rendering. This isn't something we will cover today. This volume rendering can be very in-depth, but I just want to mention it. And so this is casting rays through your data and applying transfer functions. And so it's a way that you can apply opacity and other techniques to your data to see through and into the interior of your data without clipping or doing that sort of thing. And so isosurfacing, this is another one that's really useful. So this extracts surfaces that represent a level set of field values. So if you think about what that means, so it's similar to what we saw earlier in the pseudo-color rendering. when you think about it in 2D, an isosurface, if you're following these lines along this elevation map, one line represents one elevation. And so that's an isosurface in 2D. And so then you can extend that into 3D, and so you're following the same value throughout this entire data set in 3D and creating a surface out of it. And so it's a way to see where, so if you have a known value of interest, you can set that as an isosurface and see where that is within your data and what kind of shapes it's forming and how it progresses through time. Next is particle advection, and so this is a good one that we'll get into a little bit with streamlines if we have time at the end. And so this is so like I said, this is the foundation for flow visualization. So streamlines is one of those that we'll take a look at towards the end here. And here's an example of streamlines in a box. And so you have the vector fields in the box, so that you have the flow field of how things are going to flow, and a streamline is tracing a massless particle through time, through the box, and then applying a color to it based on a number of different coloring methods. Yeah, sorry, go ahead. Sure. It depends. You can do a time dependent, and that would be called streamlines. You have path lines, so that's your time dependent. Streamlines are actually instantaneous, non-time dependent. So it's following a massless particle through a number of steps, and so there's a number of different ways you can do that. So a streamline is following a massless particle on a static time state, and you're just progressing X number of steps, and X is what you can define and what you're interested in. If you want to do a path line, that is taking a time varying flow field and then following that particle from time step to time step. Yeah, so good question. All right, and then this is one of the last things here, and this is one of the most important things with Pair View and VisIt when we start talking about HPC, is our domain decomposed meshes. And so this is how Shaheen and Ibex can take advantage of your data. And so what I mean by domains is you're seeing an example here. So on the right, we have a cube. Each of those colors represents one domain. And what a domain is it's a logical chunk of data that VisIt or Pair View can read, and they can read that independently of all of the other chunks. And so you can read something in parallel across the entirety of Shaheen. In this case, that's like 1,024 different ranks or something that you could read off of, all at the same time to speed up your computations. And so I'll mention a little bit about Ibex and Shaheen right at the end. We have other workshops that go into that advanced workflow techniques. All right. And so we're going to take a quick 10-minute pause right here, get everybody in here to download your data, download VisIt, open it up, and then we're going to jump into a tour of the VisIt interface and start working on visualizations. So I will do a quick transition, break. Okay, welcome back. We are back live again. So let's go ahead and start taking a look at VisIt. And let's jump into an interface tour of VisIt. So for those of you in the room, my slides will now be on the side TVs. So if you want to see what I'm talking about, they're going to be on the TVs on the side of the room. So to start off with, VisIt GUI, when you open it up, you should see two different windows. You'll have your window with all the pull-down menus, as well as a window called Window 1, which will be your plot window, and this is where your visualizations will show up. And so on the left-hand side, this is on, it'd be easier to stand up and do this. So on the left-hand side, active window, that will let you have any number of different windows showing plots. And so this is a plot window. So you can have any number of these different plot windows set up, and by selecting this pull down, you can see which one you're going to be doing the visualizations on. And so I only have one open, so I can only select one in this case. But if I open 4 different windows, I can then have 4 different plots, or 4 different active windows, and I can select which one I want to do a plot into. So the next thing of interest is opening and closing. So where do you open your data sources? You go to open, and then a file window open, and you can select your data source. Once your data source is open, you can add and delete plots and operators down here in the plots and operators section. And they will show up here in this middle area as a graph, essentially, of how the plots are being connected together. This area down here at the bottom is called your notepad, and so this is an area that I like to stick two different things. I like to put an engine window, which the engine in VisIt is what it's doing in the back end. It's where it's processing your data and where it's running. And so if you're running on Ibex, for instance, you'll see an Ibex engine, and you'll see how many cores you have available, how many nodes you have available, and what VisIt is doing at any given time. And the other thing is the file info. And so this is something we will discuss here in just a minute. And so when you open a file, this will give you what VisIt thinks that file is and what it can see. And so you can see if it sees what you think should be there. So that's the basic GUI tour. So now let's move on to actually just doing a few different things. So the first thing, let's open a file. So let's start off with the data from the VisIt 101 data folder. So as long as you have that downloaded, you should be good to go. And we're going to use the file called noise.silo. And silo is just a container format. It's a container format from one of the national labs in the US that they use for their physics codes. If we go to open, I'll go to my desktop. That's where I stuck my data. And so it will be in VisIt 101 data. And just click on noise.silo. And you'll see down here, VisIt is going to guess from file name extension. So it can generally know how to open a file. But if it doesn't, you can tell it exactly what file you have, and then it will use that very specific reader. You can see there's a ton of different readers in here that it can read different file formats off of. And if none of those work, you can, of course, write your own reader and then read your own special format of data that way. But for this case, Silo is well known, so we'll just let it guess. Click open, and it'll probably look like it did nothing. And so that's one thing that people get confused with initially in peer review and VisIt. When you open a file, nothing actually happens. And that's on purpose. Because these two programs work with very large data, the idea is not to do any operations that could be expensive. So if you display data, that could actually take a long time, depending on how big your data is. And so it doesn't want to do anything until you tell it to do so. And so I mentioned the file info in my notepad area down here. And so one reason I like to have that open is I can see what's going on. And so for everybody who doesn't have that available yet, you can get the file information from going to File, File Information, or on the Mac it looks like Command-I will work. And so then this will open your file information, and you can see what VisIt thinks this file is. And so it's telling you what the database is, which is a file, noise.silo in this case. It's telling you the file format. It's telling you how many time steps are in there. In this case, we only have one time step. And then it's telling you what meshes it sees. And so it sees one mesh called mesh, and then one mesh called mesh 2D. So there's a 2D mesh in there as well. And it also has a point mesh. And so there's a cell mesh and a point mesh. And then it has all these different variables defined on those meshes. So this is a great way just to see if VisIt read your file correctly and if things are working the way that you think they should. So that's why I always post this down in the notepad area so that I have it ready to go. So once we have a file open and we viewed our file info, so now how do we navigate views? And so let's go back to one view. All right. Oh man, now my window went away. Let's see. Layouts 1x2. Okay. Close that. And so when you have VisIt here, you're going to see a number of different buttons to press. So one thing that I will do today is flip this black-white reverse button. That'll change the background to black. Makes it a little less obnoxious when you're looking at your data if it's not so bright in your face. And so we will take a look at the rest of these buttons as soon as we start working on a file. Yeah, go ahead. Sorry? Ah, okay, sure. Yeah, you're fine, not a problem. We can definitely slow it down a little bit. All right, so let's go ahead and actually put a plot in this window because we need a plot there to actually see what any of these window operations do. And so how do we do that? So we go back to our window here. All right, I've confused it. Window 2. noise.silo. All right. And so once you have your file open, noise.silo, you can see that in your active source. That's what it's going to be creating a plot off of. And so then once you have that selected, as I do, you go down to add, and this is how you create plots in VisIt. So the most basic plot in VisIt, as we talked about earlier, is a pseudo-color. So just scroll down to pseudo-color, and then you can see all the different variables in that file. And we can just select whatever one you want. I usually go with Hardy Global. It's an interesting one. And apparently I've crashed VisIt, so that's a fun start to the day. Let me reopen my program, and we'll go back to it. No, I don't want to recover. All right, so I'll reopen my file. Desktop. Okay. So then I'll re-add the pseudo-color of Hardy Global. And then again, you'll notice it did nothing, and that's on purpose. Green means that it's in a good state, yet it hasn't executed. So if you're seeing green down here in this plot window, that's good. That means it's set up a pipeline, but it hasn't executed the pipeline. To execute the pipeline, click Draw, and then we'll actually go and do the work. Now you have a plot. And so now how do we interact with our plots in our plot window? So left mouse button, you can click anywhere in the plot and then drag while you're holding, and that will rotate the plot around in any number of given directions. That's your left mouse button. Click and drag, and so you can get any different views that you want that way. If you want to zoom out from your data, you feel like you're too close, you can do that with your scroll wheel. So when you're using VisIt and ParaView, a external mouse is your friend. Using the trackpad is not a lot of fun with these applications if you're doing a lot of different work. So scroll out, and you can scroll in, very easy. If you click your middle mouse button and hold, you can push your mouse forward and back, and you can get a very fine zoom, whereas if you're using your scroll wheel, you'll get click zooms, which might be too much in some cases. So if you click and hold your middle mouse button, you can pull back to the exact zoom that you want. Now let's say that we don't like this plot being centered in the window. How do we move the plot left to right, up or down? On a Mac, it's Command. I think other machines, Shift works as well. Hold down the Shift key, use your left mouse button, click, and then you can drag the plot around to wherever you want to drag the plot to. So those are the very basic movement operations of VisIt. Hold down the Command or hold down Shift, left mouse button, click and drag, left mouse button, click, spin, and then your middle mouse wheel, zoom in and out. So those are basic window operations. Some different tools that we have. So now that we have a plot in here, we can see that these tools are now active on the window view. This one here, with a camera with some weird green lines around it, is a reset view. And so you click that, that'll go back to the basic view that VisIt was in when it opened the file. That's also a very helpful tool to have when you are loading additional files. So if you have different files that have different meshes, the meshes may not always line up. They won't be the same scale necessarily. And so you may not actually see all of your data. And so by clicking Reset View, VisIt will zoom out to a spot where it will put all of your data on screen. And so it's a good way to recover if you've gotten lost in what you're looking at. Another one is Recenter. And then, so that lets you choose a different center of your data. I don't usually use that one too much. And then for everybody who likes, let's choose center of rotation. Where is the unlock one? To choose center of rotation, we can choose a different area where VisIt will rotate from. That's the one that I don't usually use too much. Now it's spinning from the corner, and it's harder to see. So that's what recenter view will do, is put the view back in the center of your data. So the view in VisIt is generally in the very center of your mesh, and so it will rotate around that center point when you're doing your rotations. Okay, so that's very basic, just looking at a plot. Now let's say that you want to look at more than one plot. So we want to have more than one window open. So in this case, I will just click this little square box here by 2 by 2, and this will create a 2 by 2 layout of windows, assuming that it works, which apparently it's not working today. That's weird. That's why VisIt crashed earlier, I think. Interesting. So assuming that the 4 by 4 layout doesn't work, the way that I actually like to do it is by clicking clone, because then I have the same plot in every window, because often I'm going to apply different operations and I want to see what they look like comparatively. And so now, oh wait, now we've frozen everything. That's even better. Dun, dun, dun. There we go. Give it a second here. Not 3.4.1 download. Well, Tom may have to take over here. Apparently I've broken my computer. Give it a second. Dun, dun, dun. So if you have any questions, now would be a good time as we're waiting for things to decide to load. Yeah, we could do that. All right, we'll transition here real quick and be right back. Transition back. All right, welcome back, everybody. Sorry again for the technical issues. So now that we've gotten our data open, we've learned how to move the data around using our mouse buttons. We've learned a little bit about the windows. So let's go ahead and take a look at our operators. So once you have a plot, that's just the most basic way to view data. So a pseudocolor plot visualizes all of the data at once, but you want to be able to apply operators to that data to manipulate its representation. And so how you do that is by clicking on the operator. So you click on the plot you want to add an operator to. In this case, it's this pseudocolor plot. And then in your window over here, there's an operators button. Click the operators button, and it'll open up the menu of all the different operators that you have in VisIt. So the most basic ones you'll want to apply are transforms. This is where you can elevate your data, you can change coordinate systems, that sort of thing. Those are a little bit more advanced. Something else you'll also want to be able to do is slices. So you can do isosurfacing, you can view 2D slices, you can view spherical slices, cones, and that kind of thing. And then also selections, and so these are also interesting. So you can cut parts of your data away with a selection and leave the rest behind. You can do that through selecting boxes, doing a clip, which is just taking off a predefined portion, or you can even do thresholds and remove data that's above or below a given range, if you know a range of data that you want to look at. So in this case, let's just go ahead and add a threshold. Let's get rid of some of this data. And so come down to your window again, where you have your graph of what's being applied, and then double click on the threshold. That'll bring up your threshold options. And this is how you can change the options within a threshold. So when it opens up, it will show you that it's doing a lower bound of minimum and a lower bound of maximum. So it's thresholding nothing away. It's letting you see all of your data. So by default, it's going to do nothing. And so what we want to do in this case, double click in the minimum and change our values. And so I saw a minute ago that looked like the data went down to 1.5 or something. So let's say I want to have a minimum value of 3. So I'll put 3, click apply. And again, nothing's going to happen because you're in SciViz tool. So you have to actually click draw when you want it to actually do the work. So we click draw, and now it's taken away any data that is below the value 3. And so that's actually not entirely true. So there's a show zone if, and so this is a little bit more complicated. So this will show you a piece of data if part of that cell has the value 3. Not the whole thing. So I usually sometimes depending on what you want to do, you can apply all in range. And so this means that every value within a cell has to be 3 or greater. And you'll see that'll actually take away more data in this case. So once we do that, it still looks like our data is being colored by the min and max of the full data, which in this case I don't want to do. And so how do I change my coloring? I can do that by going to the pseudo-color plot again, down here in the graph window, and double-clicking pseudo-color. And so this is how you can change the options of a pseudo-color plot. And so right now, the limits, and that's the important part that we're talking about, the limits, the min and max of the data, it's using the original data. And so VisIt has an idea of original data versus actual data. And so there's original data or actual data. And so what it means by actual data is once you apply a threshold operator, your actual data in the current plot is different than the original data. And so if you want to color by your actual data, you can do that. And now it will color based on the values of the data that are actually in the data set. And so in this case, it'll color between 3 and 4.91, as you can see it did here, a min of 3 and a max of 4.91. And so that changes our view substantially in this case. If you don't like this default color map, you have lots of different options. You can select that through the color table option here. So I'll click on the color table. Let's say that we are interested in an X-ray view. Not too interesting here, but you can color it by black and white. So X-ray in this case. Let's say we want to look at it in blue. And so this is highly dependent on what your use case is, depending on what color table you want to use. I often use hot desaturated just for basic plot viewing, just because it's a wide-ranging color map that lets you see the differences fairly easily. Sometimes it's not the most pretty, but it lets you see the changes and variations in data very easily by using hot desaturated. But a lot of it's up to personal choice what color table you want to use. And something else you can do, let's say that you don't like the legend, you can turn your legend on and off from this window as well. And so click apply, now my legend's gone. In this case, we'll go ahead and keep it. So that's how you can change some of the stuff that's listed on the screen. And so something else that some other people were pointing out, some of these labels are kind of annoying on the screen. I don't really want to see my database title and what cycle I'm on most of the time. So you can change that by going to controls and annotation, and this is how you can control all of the different annotations used in the VisIt window. So I generally turn off this check mark for database. I turn off user information. User information is in the lower right down here. It's your username and the time and date. I usually don't care about that on my renderings, so I turn those off. Cleans up the plot window a little bit that way. And then if you like, you can see for some reason my triad down here, this XYZ coordinate system's not showing up on this Mac. That's interesting. Maybe it's all white. Nope, doesn't even show up with the black background. So if you want to change your triad color, you can actually do that too by clicking on 3D under annotation, and you can change your triad color. Maybe it's just a line width issue. Make the lines thicker. No. Actually, I think it selected black in this case. It did. So we'll go select a random color. Why are we all selecting black? All right, let's select blue. And then apply. All right, so there my triad showed up again in a very ghastly blue color. For today, we'll go ahead and leave that. And let's see, I also often like my legends to be horizontal. So this is getting a little bit into if you want to do a rendering. But so if you go to objects, you can see all of the different annotation objects in the screen. And so here's a way you can actually add text. So I use this if I have a map that I'm rendering and I want to have a label for a city or something. You can add text and overlay that on the screen. You can see that, put 2D text annotation, and put whatever you want in there. This is text, and apply, and then you can, where did it go? You can select your layout with this very rudimentary layout tool. Put it up here in the upper left. So delete that. I don't want that. So the point of this was you can change your orientation of your color bars. So it always starts vertical, text on right. I usually do horizontal, text on top for a lot of the things that I do. Then that'll give you a little different view of your color table that way. Let's see, what else can we do in here that's interesting? So some other things I like to do, sometimes I turn off show axes, because this plot's kind of busy. So if I turn that off, nope, that's not what I like to turn off. My bad. I like to turn off show bounding box. There we go. I turn off show bounding box. That way it removes all of the extra lines and it just keeps your triad there, so you can see what your data extents are. So I usually I think it looks cleaner, a little less annoying to look at. So I turn that off as well. And I usually do use a darker background. So you saw me a minute ago use this toggle button. This is toggling the foreground and background color in VisIt. And that's something that you can set in colors. You can set your foreground and your background color here. Another thing that I like is actually to have a gradient background. So we can do a gradient. You can apply a gradient color on your background. And that's a horrible blue, but we can change that to make it something a little bit nicer. Make a darker blue, maybe not have that be quite so dark. Black would be a grayish color there. That kind of makes a little bit more interesting to look at, and it's a little nicer when you're doing renderings. It all depends on your use case. But when I'm working, I usually set something like this. All right, so that's a little bit about the annotations in VisIt. And then, all right, one more important thing that will probably bite you, as you can see, is the selectively applying operators. And so when you first download VisIt, it'll often have something that says apply to active window, and it will have these two checkboxes checked: apply operators to all plots and apply subset selections to all plots. This is fine until you start adding multiple plots. So let's say that I want to add another plot in here of a different variable. Say I want to add another pseudocolor, so I go to add pseudocolor. I pick a different variable. Let's say this case we'll do shepherd global. But what you're going to see is shepherd global has also been thresholded. Now, that may or may not be a good thing, depending on what you're doing. So usually, you don't want to threshold everything by the same value. And you see I deleted that threshold, and it deleted it from both. The reason it's doing that is the apply operator to all plots button is checked over here. So I will always turn those off unless I really want every plot to have the exact same operators. Because now I have to go back and recreate that threshold that I created because I just deleted it, because I deleted the one from the other plot. So that's something that will end up biting you eventually if you leave these checked. So I always uncheck those and only apply operators to the plots that I'm currently working on. So I'll go back and add my threshold back in there. So I just want to mention that because in a while we'll be doing more than one plot on the screen, and if it's applying the same filter to all of your data, it's not going to work. All right, and so that's essentially all I wanted to talk about. One more thing that might be interesting is linking views. And so when I will clone this window, and so now I have two different windows, so right before my visit crashed, that's what I was going to tell you about, is cloning windows. I like to clone because it keeps your background color the same. It keeps all of your settings the same from window to window. If you use the layout button, it will create new instances of window that have different colors and different label annotations and all of that stuff. So I don't like using these layout boxes, the 2x2, 4x4, whatever. I always do this clone button, which is a window with a blue arrow going to another window. So this is clone. It'll clone your current window into a new one. The benefit of that also is it puts all of the plots from your last window into this window. The one thing I didn't mention was hide and show. This is something I use all the time. So over here in the controls, so I have two different plots that are overlapping each other right here. You can see that they're fighting to be seen. So that's not what I want to have right now. So let's say I want to get rid of my hardy global plot. So and I don't want to delete it. Maybe I want to look at it later. Click hide. Now it's gone. So now it's out of your way. You don't have to worry about it. And so now I've got a different variable being displayed versus what I have in window 1. But let's say that we want to take a look at the same point on these two different windows at the same time. So that's what I'm talking about when I say link views. And so there's a little lock with an I button up here on your taskbar. Click that in both windows. The lock button with an I. Click that on both windows, and now both windows will rotate to the exact same position. So I'm only clicking in the left window and dragging it, and the right window is moving to respond. So you're looking in the same location in both windows. It'll do zoom and everything. It'll pan, so I'm panning right now. So all of your windows will be linked. That's what I mean by linking views. Sometimes it's interesting and useful, sometimes it's not. It's good to know it's there if you need it. I will turn that back off. And so that really covers the GUI tour in VisIt. So the next thing we'll do is we'll jump into another hands-on session. But before we do that, are there any questions that anybody wants to ask? Sorry? I can't hear you. Well, if there's a lot of questions, I will. Otherwise, we need to move on because I've wasted too much time with my broken laptop. All right, so any questions that I can answer? Is that you? Yeah, go ahead. Yes, you can do expressions. You can create your own variables based on expressions. So the question was, yeah, thank you. The question was, so if I have data and I want to do an analysis on, essentially, this is the question. I'm paraphrasing. So sorry if it's not exactly the correct for the rephrase. But if we want to take your available variables and create a derived expression from that, there is an expression operator in VisIt that I will show you later that can do that. That's under controls expressions. And so you can define new expressions here. And so we'll go through this in the next data set actually and create a vector field based on some data. So where can you see the variables? The variables are all available. So that's a good question. So if you have an existing plot down here, let me zoom back out. My mouse isn't working. Zoom back out. So I'll select this plot. You can see all the variables that are in the data set by clicking variable over here on the right-hand side. And so this will show you all the current variables in this data set. There's quite a few. It's like you can actually switch your variable to a different data. You can actually switch a plot to a different variable over here as well on the fly if you want to see something else. So Hardy Global versus Shepherd Global, for instance. Yep. Any other questions? All right. Yeah, go ahead. Sorry. Did you hear the question, Tom? We've got a mic I can pass around, but I'll walk back here. Sorry, can you go ahead and repeat your question? Yeah. You lost all the information on the second page. So it's actually still here. So you can see it's green. That means that your graph is ready to execute but has not been executed. You have to click draw. And so that's a VisIt and ParaView idiosyncrasy where it doesn't do something unless you tell it to do something because it could be very expensive. It could take a long time. Yeah. Yeah. Okay. Yeah. Mm-hmm. Yes. Yes. Yeah. So the question is, so if you have data on Ibex, what's a good way to visualize that? And so it really depends on the size of the data. Are we talking big data? Is it hard to transfer? Okay. Okay. So they're fairly small, but still you don't want to be moving them. So the best way, honestly, is client server. Are you having issues with client server on Ibex? Okay. You shouldn't be. It should work very well. And we have client server working on Shaheen as well. And Shaheen is emptier than Ibex. So send me an email after the course and let me know what your issues are. 'Cause if you're having issues, we need to know about them. Okay. Yeah. Oh, okay. Yeah. Send us an email. We'll happily figure out a better workflow that'll work for Ibex. Yeah. Yeah, no problem. Okay. All right. Any last questions, or we'll move on to the second hands-on step. Okay. Can you repeat that? I show the data. What do you mean by that? Oh, this is a toy data set from VisIt. This is from just this is one of the example. How many levels it is? Labels. You mean the different variables available in there? Yeah, so if you want to see the different variables, you can click on the variable button and that'll tell you the different variables that are on that mesh. So all of these are variables on that mesh. And so right now on the screen, I'm looking at Shepherd Global, for instance. Another way that you can see what's in the file is if you go to File and then File Information. This will tell you all of the information VisIt sees in the file. It has 3 different meshes it saw, and these are all the variables in there. Yeah, not a problem. All right, so I will move on now to the second hands-on exercise, if I can wake up my PowerPoint laptop. So we're going to get into doing a few more operators, essentially. So we've already started doing basic plots in this the GUI tour, but we're going to move on to doing some more slices and contours now. And so for this one, I was already seeing some people were saying they can't load this Arabian Gulf data set because their laptops were not liking it. If that's the case, you can try and follow along with the second data set that I gave you. You won't be able to do some of the vector stuff if you're not able to load the Arabian Gulf data set. But so go ahead and close out, delete your plots, go ahead and close your active source. So delete plots first and then click close. That'll close your database, and now let's open a new database. So we're going to go back to open, and so I need to, in this case, open the Arabian Gulf file. So I'll open arabiangulf.vtu. So this is a VTK dataset unstructured, is what that file format stands for. And so it has opened. And so before you do anything, I want you to open another dataset. So go to open the bathy file. So this is a bathymetry file, and this is a .nc. So this is a file that we got from a simulation. And so double click on that. VisIt knows how to read these as well. And so now that file is open. And so this is the one that we want to start working with first. So what a bathymetry is, so if you're talking about, say, the Arabian Gulf, the bathymetry is going to give you the elevation. And so let's go ahead and take a look at what the elevation around the Arabian Gulf looks like. So if we go to add, once you have the active source of bathy ag1km.nc, go to add, go to pseudocolor, and there's only one variable in this file called bathy. So click that, it shows up as green, meaning that your graph is ready to execute, and then click draw. And you'll see that we have a 2D image. So this is our bathymetry of the Arabian Gulf. Not too interesting yet, but that's where operators come in. So we're going to apply operators now to get the height field out of this bathymetry file. Any issues opening the file so far? No, you cannot open 2D and 3D at the same time. That means you have a plot that's active in your window. Delete or hide your plots. So the question was, VisIt spit up an error message saying you cannot have a 2D plot and a 3D plot active simultaneously. This is true. Everything has to either be 2D or everything has to be 3D. And I'll show you how to make things 3D here in a second with this 2D file. So with this bathymetry pseudocolor created, we need to apply an operator. So have it selected, go to operators, and then we're going to go down and we're going to do a transformation on this. And the transform that we want to do is an elevation. We need to get our elevation out of this file. So click elevate, your plot goes away, everything's green and happy. Double click on elevate and bring up the elevate options. And so in this case, if you want to do nothing, you can say elevate with 0 height. And so this is a way to get rid of your message if you have a 2D data set that you want to display with a 3D data set. You can have it elevated with 0 height, which will make it 3D in VisIt's world. So you can click elevate with 0 height, apply, and draw. It'll still be 2D, but now it's in a 3D view. And so now you could put other 3D plots on top of this, and VisIt will be happy. So that's one way to get rid of that message. If you don't want to change your 2D plot into 3D for real, you can pretend by telling VisIt that it's 3D, and it'll end up being happy. But that's not what we want to do to get our height out of this. So I'll uncheck that, and I will say scale elevation height always. I always want to scale the elevation height. And we're going to do just a linear scale today. We'll go ahead and set a minimum and a maximum. We'll leave the minimum at 0, and the maximum will be 10,000, for instance. And so what this is going to do is this is going to take every pixel and scale it or every point on this mesh and scale it by the magnitude of the intensity of these pixel values. So go ahead and click apply. VisIt will think for a minute, and you've got a very basic bathymetry file for the Arabian Gulf created. And so in this instance, it kind of gives you an interesting scale of what the depth of the ocean is at the inlet to the Arabian Gulf versus what the Arabian Gulf actually is. So you can see out here at the inlet to the Arabian Gulf. So let me see. Does everybody know what the Arabian Gulf looks like? I don't always remember. The Arabian Gulf is in this interesting shape right here. You've got Qatar over here. And so if you take a look at our data set, it's hard to see because it's all red. We'll see it in a second. But there's a flat portion right here. That's Qatar. And then we've got the inlet down here at the Gulf of Oman. And that's where things start to really get deep in our data set, as you can see. So we've got things get really deep out there in the Gulf of Oman. But the Arabian Gulf itself is actually fairly shallow, which you'll see some of that when we start looking at the salinity values in the Arabian Gulf and how much higher they are than out in the Gulf of Oman. So now, has everybody been able to elevate this data set? Any issues doing an elevation? Oops, sorry. Need to minimize this window, it's in my way. Any elevation issues? All right. So now that we've elevated it, I want to go ahead and create a slice. So what I want to get out of this is just the bounds of the Arabian Gulf. We're going to use this in the next plots. So I'm going to do another operator on this. We're going to go to operators. I'm going to go to slicing. I'm going to say slice. And so now it's going to apply a slice. And so something we haven't seen until now is when you have multiple operators, you can change your ordering here. And so this is important actually when you're doing certain things. And for today, this is actually what we want to do. We want to elevate it first and then create a slice. And so VisIt's going to apply the operators from top to bottom. It's going to do an elevation, then it'll do a slice, and then it will pseudo-color that slice. And so that's the order of operations in this VisIt graph. And so that's perfect. I want it elevated before I slice it. So double click on slice, and we need to change our slice settings. So I want to slice along the z-axis, that's the height. So the z-axis will give us a nice plane of the Arabian Gulf. So change your orthogonal axis to z. I like doing percent. That makes it easier. I don't have to choose a real number. So I'm going to choose a percent. I'm going to choose, say, 33% of the way through the z-axis. I want to create a slice. Let's just see what that looks like. So click apply, click draw, and let's see what it decides to do. All right, so what we're seeing is VisIt is working from bottom to top. So 30% of the way up, so it's going up. So if we want to get the top of the Arabian Gulf, we want to go to 100% of our slice plane. So I'll go to 100%, and then we should get the sea surface. So this will be the sea surface now of the Arabian Gulf. And that's exactly what I wanted to see, was a nice little outline that we can use in our next visualizations. Something you'll want to turn off, which I forgot to tell you about, is project to 2D. I don't want to project this back to 2D. I want to keep this as a 3D slice so that I can use this in other plots. So uncheck project to 2D and then reapply. And now you can see where it was slicing. It was slicing at the surface over here. So if you want to see what other slices look like and you want to keep that one, we can do that easily. You can click on your full pipeline here and then right click on it, and then you can bring up your window and you'll find something called clone. So you can clone this pipeline into another one. And this is a good way to do the same plot again, but with different options. Sure. Yeah, where are you at? We can all right. The question was, can we slow down? I apologize for being fast. I'm repeating myself for the online audience. Sorry if I sound crazy over here. So slice. So I'm going to change my slice on this second plot to something, say 70 or 69%. And we'll see what 69% looks like. And so what I think we actually have to click draw as well. And then once we click draw, we'll have a 69% slice. And so that's actually not high enough. So we can see the Gulf is very shallow over there. And so what this is essentially doing, this is creating a contour plot. So this is a way to create a contour plot as well. This is the field value that's equal across the entire across this entire surface. So I'm going to delete the second plot now. That was just to show you how to do a clone. I only care about keeping the top one. Let's say I don't like the red color, which I don't. So I'm going to double click again on pseudo color, and I'm going to change my coloring. So in this case, it's using a color table, which I don't like. So I'm going to turn off the legend because I don't want to see what the color table of my slice is. And I'm going to choose one that has a white. So in this instance, I'm going to choose green, blue, and I'm going to do apply. So now it's going to be at the far right of that. So I want to invert the color table. And then it will use the beginning of this color table. And now we have a nice white border, which is what I want for the next plot, because this is going to sit on top of our next plot. Let's see. One thing I wanted to also do is you can change your geometry of these slice lines. So right now they're being rendered as lines, which is fine. I'll just make the lines a little bit bigger so that they show up better. Say, increase them to a line width of 4. So that looks okay. Okay, and so that's, and so, oh yeah, so let's go back to these, to our scale lines here. I actually don't like how those are being rendered because they're being rendered right over top of the data I'm trying to look at. So under annotation, you can actually change how the tick marks are done. So right now it's set to draw these on the closest triad, which is the closest view to you, the user. So I usually set that to furthest triad in these cases. So now it's going to put the lines at the back of the plot, and so they're not directly in my way. It makes it a little bit cleaner when you're looking at the data. All right, so now that's the end of this 2D file. So we can just, I'm going to minimize that pipeline, but I want to keep it there. Now how do we work on the next plot? You need to change your active source, and so that's under active sources. So now we want to go to the Arabian Gulf file. And now we can create plots based on the values in the Arabian Gulf file. And so I'll go to add once I have an active source of Arabian Gulf.vtu. I will then go to pseudo color, and we only have 2 variables that we care about right now. We have temperature and we have salinity. So I will do salinity this time, assuming that VisIt is happy. There we go. So it read the file, created me a pseudo-color plot of salinity. I'll go ahead and draw that, see what it looks like. I think we're going to have an interesting issue here where the data is not going to line up with the plot we just created, and it's not. So the Arabian Gulf.vtu file is actually inverted. So this is what the file would look like, and that's not what the Arabian Gulf looks like. So we need to apply an operator to this data so that it displays correctly. And to do that, you can actually just do an inversion of your z coordinates in VisIt very easily. So to do that, click on your salinity plot again of pseudo-color, go to operators, and do a transform. And so a transform, again, is usually manipulating the mesh. And so in this case, it's literally called transform down here at the bottom. Once you have the transform in your pipeline, double click on it, and it will bring up your pipeline options. And so in this case, we're just going to go to a linear transform, and we're going to change our matrix transform here. So what this is your x, y, and z. And so I want to just invert my z coordinates. All I have to do is just do a -1 in the z column, and that will invert the z coordinates in the data. So apply, and then draw. And suddenly my data is fine again. So now the data is going the right direction. It looks physical to the real world, and it sits over top nicely of our contour plot that we did a few minutes ago. And that's why I wanted it to be white, so that it would have a nice contrast with the data that we were creating here. And I was wondering myself why this didn't look good over there, and it looks like that's just cut off weird. So we can investigate that later. Okay, and so this is what the salinity of the Arabian Gulf looks like. I think this must have been early spring because it's not very high right now. But what you can see actually is this really high salinity value over here by Oman. And so if you look at this from the side, you can see that's a really shallow area. And so so that you're aware, this is actually an exaggerated scale in VisIt. So we've actually stretched this out a little bit so you can see it better. It's actually a really, really, really shallow area. And so that's why it's so much more it has such a higher salinity versus the rest of the Arabian Gulf. Plus, you're not getting a lot of flow and mixture through there. And so that's something that we'll look a little bit at when we look at vectors and streamlines, is what the flow of the Arabian Gulf looks like at that particular time of year. All right, and so that's creating the Arabian Gulf. That's doing the contour lines. Let's see, what time are we getting to? 3 o'clock. Okay, we've still got, how did we start? We've got 40 minutes. So that we need about 30 minutes for the next session. So at this point, I think we should go ahead and do our 10-minute coffee break. We'll walk around, see if anybody's having any issues, and then we'll come back and start looking at the next hands-on session. So for everybody online, thank you. We will be back here in 10 minutes. All right, welcome back, everybody. That was a very quick 10-minute break. So hopefully everybody has gotten to a point where they're happy with viewing the Arabian Gulf, doing a contour, doing a pseudo-color, and then inverting the Arabian Gulf in the z direction so that it lines up with our contour. So what we want to do now is move on to a number of different things that you can do with VisIt that will maybe help you with your papers, help you with presentations, and so forth. So screenshots, movies, animations, custom expressions, queries, even, and saving your VisIt state. So we may not get to all of this in the next 30 minutes, but it'll be in the slides if you have questions on it. So what I'm going to do actually is skip to the part that still uses the Arabian Gulf file so that we don't have to redo things. So something interesting that you can do with VisIt, of course, is you can query your data. You have underlying data that's associated with each of these points on the mesh, and you can ask VisIt what that data is if you're interested. So let's say that I'm very interested in knowing what the actual salinity value is at a specific point over here on my plot. I'll say I'll zoom into it. I can tell that it's between, say, 58 and 69 over here, but I don't know exactly what it is because the color map isn't super specific. So what I can do is I can do a pick. And so what a pick is in VisIt is it takes a point on the mesh and asks the data set what those values are at that point. And so I'll just, I'll pick a zone in this case. And so there's down here, oh, and I guess we didn't mention these tools earlier. So when VisIt opens, you're going to be selected on this navigation mode, and that lets you do your basic navigation. Something else you can also do is click on the magnifying glass, which puts you in a zoom mode. You can drag a box around what you're interested in seeing, and it'll zoom into that area. So if you're stuck and this VisIt's doing weird things, you may need to select navigation mode again so that you can get back to where you're able to navigate again. But so I'm going to zoom back into this data, and I'm going to be interested in doing a pick. So a pick is you can pick by nodes, zones, or cells. So I'll just do a Z pick, and it gives you a little crosshair so you can go along your data, pick an interesting spot, click, and then it went and queried the underlying data set, put a label, say I did pick A, and it's going to tell me what it found in that area. So it found that it's querying the Arabian Gulf.vtu file. It's looking at this mesh. It's looking at this exact point in that mesh, and this exact zone, which is the cell number in this case, and these are the cells that border that cell, and so it's telling you the value of that exact cell. So we were finding it's incident nodes. So right where we picked, incident nodes 11427. All right, yeah, so we're getting a value right there of 37.09. So this is a way that you can do a quick query of your data through a pick. So I shouldn't have used the word query there because there's also queries in VisIt. So this is picks, which gives you the actual underlying data. queries are another thing. So if you go to controls in VisIt, you can go down to the query option, and this lets you actually ask other questions of your data without actually clicking on the screen. So let's say that I have questions about my mesh. And so I'm going to go to mesh-related queries, say what is my 3D surface area of this mesh, and ask VisIt. It'll go do some calculations. My total surface area is 132.62. So you can actually do custom queries in Python. You can do all kinds of stuff and ask VisIt to do queries and do manipulations on your data. So some other things you might want to know about. Maybe I want to know what the number of zones are. And this is also interesting. It uses actual data and original data like we talked about earlier. So if you do an operation on your data and you want to know what the data looks like in that data set that you've created from that operation, use actual data versus original data. See some grid information. We can ask what kind of grid this is. This is an unstructured mesh with these dimensions. So queries, very basic most of the time. You can do a lot of other stuff in here. You can do time-related queries, and some of these are going to be, actually, let's see, variable-related queries. Some of these are very interesting. So you can do like a min-max over time, average over time of variables if you have a time-varying data set. So we don't have time in this file, so none of this is going to work in terms of time. We can take a look at a time-varying data set in a few minutes. So that's picks and queries. Any questions on picks or queries? Excellent. So next, we'll take a look at vector plots. We won't do the well, we might do the streamlines. So I want to do the vector plots because this will do the custom expression that was asked about earlier. So we need to go to controls and go to expressions. This will let you create a custom expression. So in this case, I need to create a new custom expression, and I need to create a vector out of the data that I have in my data set. I don't have a vector created yet. I have the vector components, but I don't have the vector. So I'm going to call this the golfvec. It's going to be a type. It's going to be a vector mesh variable. So this is going to create a new variable on the mesh called golfvec. And so now that we have that set as a vector mesh variable, we create our vector. So curly brackets, insert variable, scalar variables, and we have our u velocity. So uvel, comma, space, vvel, comma, space, wvel, closing curly bracket. That's all it takes to create a vector when you have the data already available in your data set. You know that you can of course do all kinds of other functions in here. If you want to do a lot more advanced expressions, there's a Python expression editor. You can create your own expressions to create your own variables and get very in-depth in expression creation. But for this one, it's very easy. Just 3 components. Click apply. We can go ahead and close that out. Now, if you want to see the vectors, what I will do is I will hide my pseudocolor plot of the Arabian Gulf, and I will add a vector plot. So go to add vector of golfvec in this case. And this will create a vector plot. So I probably should have changed the options because it might take it a minute here to create all of these different vectors. And so it's actually inverted them again. So that's another thing that we need to take note of. I need to actually apply a transform to put them in the proper direction. So invert in the linear z direction again. Go to add, and oh wait, what do you mean? Do you mean the expression or the plot? So what plot are you trying to create? There's a vector plot you need to create. So go to add a vector. Add vector. Anybody else having trouble finding the vector plot? So it's under add, vector, and then you use your newly created vector variable. Anyone else having issues? They still have it set as a scalar mesh variable. You need to. It's all right. VisIt has to know what kind of mesh you're creating. Okay, so to create the vector, go to controls, go to expression, and this is how we can create a new expression. Click new, and then name your expression, whatever you want to name it. Yep, that's fine. And then to do the type so click on type. There's a type drop down. Change it to vector mesh, and now let's create our vector. So you do a opening curly bracket, and then go to insert variable at the bottom, and then go to scalar variables, and then insert uvel, and then comma, the other ones. So vvel and then wvel. And then closing curly bracket. And I don't think the spaces matter. So yeah, click apply. And now go to, on the VisIt window over there, go to add, and add a vector plot. And let's see if it works. Add vector, yep, www, click draw. And I would hide your pseudo-color plot first, actually once it's done drawing. So, all right, so click on your middle one, click on the middle plot, and then click the hide button. Yeah, right there. There you go. Yep, there you go. Yeah, if you already have a vector that's defined as a vector, VisIt will see it as a vector. So in this case, we didn't have a vector defined, so we had to create one. So. Yeah, you got the three directions to create your vector. Yep, exactly. Not a problem. All right, any other issues with vectors? Yeah. Yeah. Okay. So we'll just hide that. And so, yeah, so with that hidden, go to controls. I'll let you do it. It's easier to learn that way. So go to controls, go to expressions. And let's go ahead and create a new expression. You gotta click new, sorry. New down there. And then name it, whatever you want to name it. Yep. And then change your type from scalar variable to a vector variable. Yes. Yes. Vector mesh variable. That way VisIt knows this is a vector. And now we'll create our definition, which is an opening curly bracket. And then you can do, oh, there we go. There you go. Opening curly bracket. Wait, is that curly? I can't tell. Curly. That one. And then do insert variable. Go to scalars. Go to uvel. That's your velocity in the u direction. And then comma. And then put in vvel and wvel. So we could have predefined this vector on this mesh before I gave you the file, but the point was to show you how expressions worked in VisIt. So I know it's something that could have been there, but we took it out so that you would be able to create your own vectors this way. Perfect. And then click apply. And then now you can go to add. You can add a vector, and then of your vec new. So then you can click draw. So it'll think for a minute. It's got to go through and create the new variable. And then there it is. And so I'll show you some ways to make those vectors easier to see here in a second. Any other issues? Any other questions? All right. So those are pretty hard to see. I can barely see them. So how do we change that? So one way is we can scale them up and make them larger. So we can go double click on the vector plot itself, and we can change the geometry. So if you want to have the scale be 0.5, for instance, you can make them twice as big. See what that looks like. See if that's easier to see. That made them actually quite a bit bigger in this case. And another thing that we can do, but you got to be careful, is increase the number of vectors. If you increase this too high and you're on too small of a laptop, you may freeze your laptop. So I'm going to do, say, a stride instead of a fixed number. This will create a lot more vectors. So I'm going to take every 100th vector and plot it on the screen. So this is only every 100th vector plotted. So now that's a lot easier to see. I can get a lot better sense of what's happening. So if I zoom in here over at the Gulf of Oman, you can see some interesting formations actually. You've got a lot of turbulence over here. You've got eddies forming, you've got this big U shape going on where there's a current coming in and then exiting the Gulf. And then you've got actually an eddy here. There's a circle eddy there. You can kind of see through these vectors. Eddies forming here, eddies here. So you get to see a lot of interesting flow patterns by looking at vectors. You don't even have to do streamlines to see them. If you put enough vectors on your screen, you can get a sense of what's happening. You can see there's some vectors that are really large, and so those are strange looking, aren't they? So you've got some over here. And so what you're seeing here is going to be dependent on what we're visualizing. So let's see, it should be looking at the magnitude. So it's scaling the vectors by the magnitude. So this is the magnitude of those vectors. That means there's a lot of velocity over here along the coastline, which I guess kind of makes sense. You've got flow coming in from the Gulf, going through a small channel. You're maybe increasing your velocity up there. Let's see, what else do we got going on? And then another interesting thing, you've got a lot of very small velocity vectors out here in the center of the Gulf. So there's not a lot of mixing, not a lot of flow. Everything's kind of static out there. So what else can you do? You can change your glyph types. You can make ellipsoids. You can change the lines to cylinders if you want to render cylinders. That'll probably, it kind of looks better if you have large glyphs. And this cylinder is not very pretty. It doesn't let you change the geometry on these vectors. There we go. So if you do add some smoothing or add some quality, we can increase our so I went from geometric quality fast to high. And so you can tell there's quite a difference. It's a very square tubes to very round tubes, depending on your quality. So you can change your representations or your publication graphics this way, depending on what your use case is. So that's vectors. Let's see. You can also color by a constant, or you can even color by a different. Actually, you can't color these by a different variable. All right, so you can change or blue hot. I don't know, something interesting. Let's go down to saturated. Okay. So that's creating an expression. So are there any issues with creating an expression and creating a vector plot and making your vector plot look a little bit nicer? Okay, perfect. So the next thing that we can take a look at is in 10 minutes. So I'm not going to do streamlines because 10 minutes is not going to be enough to do streamlines, and then we'll skip all the other interesting stuff that we need to do. So we can talk about streamlines later on this afternoon if you are interested in hearing about those. I'm going to delete all my plots. I'm going to close all of my active sources, and I'm going to start fresh. So I need to open up the other data file that I had you download, the VisIt, sorry, not the VisIt one, the Grayscott data. So go into your Grayscott directory, and VisIt should automatically group these files as one giant file. So it'll be called the database, PVTI database, and just open all of those files. And so that file is open. I'll just do a pseudo color. There's only two variables in the Grayscott simulation. There's a U and a V. And so what Grayscott is I can actually show you what it is. If I can. Should have had that website open, but I didn't have my website open. Come on. So Grayscott, we have this in a repo that we've got here at the Visualization Lab that we'll talk about in our more advanced VisIt and Purview tutorials. So it's a mini app. So Grayscott, this is a 3D 7-point stencil code to simulate the Grayscott reaction diffusion model. So that's what it is. You can read more about it here on our Git repo, and this is kind of what it looks like depending on your settings. It's just creating. You have an activator and you have a source, and they're creating cool interactions in 3D space. So it's a toy example in this case. but it makes for interesting time-varying data. That's why we want to do this, is to look at time-varying data. Because so far we've only looked at a static time step. So time-varying data is really where visit and pair view are the most interesting. So we can't see anything right now. That's because all of the interesting data is inside. So we need to add an operator first. So what are we doing? So let's go back. The point of what we're doing now is we're going to create a screenshot and a movie. So the operator I want to apply a slice, and I want to apply a 3-slice. And so a 3-slice is a special visit thing where it creates 3 different slices simultaneously across each of the 3 different axes. So if I go to operators, slicing 3-slice, click draw, it looks like it did nothing, but that's because it sliced on the outside edges. So you've got 3 different slices of your data here. So we need to actually change those to slice somewhere more interesting. And our data goes between 0 and 6.5, it looks like. So we'll slice at 3 in all dimensions, which will get us somewhere around the middle. There we go. We can see our data is in the middle. It hasn't done anything yet because this is the first time step. So once your 3 slices there, you can actually just go ahead and play this data, and you'll notice that your time slider is now active because this is a multi-time step data set. So just click play, and it'll play through time. And since we've sliced it, we can see how the data is changing inside of this volume. It's actually a very nice simulation from how much it changes from time step to time step perspective. It's very interesting. Any issues on opening this file or creating a 3-slice so far? Issue or no issue? Okay. Okay, still need to click draw. Perfect. Now it's just sliced at the outside edge of three planes. Now we just need to change where it's slicing. So just double click on the 3-slice and set it to 3. That'll be approximately the middle of the volume, and three in each dimension because it's 3 different slices. Yeah. There you go. So now you're right in the middle, and now you can click play, and it'll play through time. Not a problem. Anyone else having issues with 3 slices? Perfect. So now that you have your most amazing visualization ever and you're ready to publish your paper, how do you get this visualization into your paper? Say this is the perfect view right here. Say that you like that. Screenshots are very easy in VisIt. All you have to do is go to File, go to, I always set your save options first. So File, Set Save Options, and change your output directory. Because right now, if you're on a Mac, it'll put it in the app directory, which is a very annoying place to have files saved. So I'll put them in my downloads folder. So output directory, downloads, file name, VisIt is fine, but we could say workshop in this case. It'll save it out as a PNG, that's fine. If you want to save it out as something else, you can. There's a bunch of different file types that you can save these out as. And let's see. And this is how you can set your width. So I'll just use screen ratio, but you can set any different width or height here. If you want a really high resolution image, you can create one of those. So then click apply, click save, and you'll notice down here at the bottom, you'll see a notice on the left-hand side that VisIt saved something. And so let's see. If you missed the message, I didn't mention this earlier, there's a little icon down here at the lower left-hand side of VisIt. This is your output window. If VisIt told you something and you missed what it said, you can click on the output window, open that up, and you can see all the messages that it's given you recently. And so the last message it gave us was that it saved this PNG where I told it to. So that's perfect. We can go take a look at that PNG. In downloads, workshop00.png, and there it is. Super easy to save screenshots. The next thing you can do is actually save movies. So if you want to see this animation play out in your slideshow, that's very easy as well. Go to File, go to Save Movie, and we'll talk about setting keyframes and stuff for movies here in a minute. But since this is a time-varying data set, you can create a movie without keyframes. It'll just create a movie over time versus rotating the camera or zooming in or doing that kind of thing. So new simple movie, just select your movie type. I often just save them out as images and then re-encode it myself later, but we'll just save it out as an MPEG, or you can do it now actually. You can save out both things. So I'll just save out a PNG and an MPEG movie. And that's good enough. Say frames per second, 10. That'll play pretty fast, but that's okay. And it will save it out to the downloads folder again. And it'll be called movie, so that's fine. And if you're on a high-powered workstation, you can actually have VisIt launch a new instance of itself and run in the background. But since this is a laptop, we'll just have it use the currently allocated processors and do the run. So you can see it's launched the CLI. This is something that we haven't talked about in this course. This is the command line interface where you can actually run VisIt from the command line if you want. And so it's going to run. It's going to create these different images and save them out to disk. Assuming that it works fast on this laptop. I haven't done this on the laptop. There we go. It is going to be fast. Okay. It's loaded it up. It's running all the different images. It's got a few more seconds to go before it finishes. And so it's saving images, and then it will encode the movie at the end. And while this is running, this is an interesting reason of why I like the engine window open. So I always post the engine window to my notepad area so that I can see what VisIt's doing. Because you can actually tell that it's working because it's got a total status, it's got stages. So if you're doing a multi-stage pipeline, sometimes that can take 5 or 10 minutes if you're working on really, really large data and it's doing really, really something complex. So you can watch its progress down here in the engine window. All right, so all of the images have saved. It's encoding the movie. The movie's been encoded, it's done. So let's go see if this worked. Okay, we've got a movie, and there it is. So basic movies are very easy in VisIt. And if you go to the annotations window that I showed you earlier, you can add titles, you can add other stuff that will render on the screen to describe your movie as well. So you don't have to add those in post-production if you don't want to. So far, any issues with screenshots or movies? Excellent. So we're almost out of time, but I think there's one more interesting thing that we want to see. So we should probably talk about save sessions, because this is one of the more important things. If you're doing a very large, complicated pipeline, you don't want to have to recreate that every time you open VisIt. So let's say that I want to add a couple more things. I want to add a operator view. I want to do something. You don't have to copy me here. I'm showing you this simply for a very quick demo of what a state is. So apply that. Draw. So let's say this is a really cool state. We want to come back and work on this tomorrow. So we go to File. We go to Save Session. So Save Session. Since this session has not been saved, it'll ask us where we want to save it, what we want to name it. Put it in Downloads. Call it VisIt Session 0 and save. And so that's all you need to do. Now you can close out, come back tomorrow, get back to work. So how to reopen a session, simply reopen your VisIt, assuming your VisIt works. Applications, VisIt, let it load. All right, so then you can come back to File, and then you can restore session. And so there's two options, restore session, and that works great if you're loading a session file on your own computer with your own data that you haven't moved. So, but let's say you want to give this session file to a colleague, and you've also sent them the data. It's not going to be at the same path that it was on your computer. So you say restore session with sources, and now if your data has moved, you can actually pick that data up from any directory. So I need to go back and actually find my session file first. That's under Downloads, VisIt 00.session, open, and now it will ask me what sources I want. So it says I have two different two different sources that were open. Actually, I don't know why it says there is, because that one doesn't seem to be a real source. But we have one source that's open. It's this PVTI database. If that path is changed, you simply go select this database from the correct path, and then it will update all of the plots to work. So then once you're ready, click OK, and you're ready to go back to work. So saving session, very important. You want to save your session if you have a very complicated pipeline you're working on and don't want to recreate everything. So, since we're at the end of the time, I'm going to wrap it up. But if we want to go over the other slides, we can after we close out the stream here. So, oh yeah, we're not showing this on all of the screens. Let me open it on the my laptop as well. So I wanted to end with some visualization best practices. We'd gotten some questions about how to visualize data on Ibex, how to visualize it on Shaheen, what size data do I want to move to my laptop versus not move to my laptop. So our general advice in this case is if your data is small or manageable, and by small I actually mean quite small, do the visualizations on your laptop. And then if your data is small or a little bit bigger but still small, do that on your desktop. Really, if your data is anywhere medium or large, you want to be keeping that on the network storage that it's already on. So do interactive visualization on Ibex, or do interactive visualization on Shaheen, or even better, do batch visualization. So that's where you just create a job with a script, and it runs everything in the background. There's no GUI involved. Everything's just done in batch. So that would be my general advice. And so how do you access those resources? They're very easy to access if you have a KAUST account. So you can access KAUST HPC resources directly from VisIt. There's something called host profiles and configuration. And so you can load the KAUST profile. And so the Shaheen 3 is not in the current profile. It will be out in 3.4.2 version of VisIt, but right now it's not. So if you want to get on Shaheen, check out this link. It will tell you how to create the profile for Shaheen 3. But the profile for Ibex is in this current version of VisIt. And so you do that simply by going to Options, Host Profiles, and Configuration Setup. And you can load the KAUST profile just by clicking on it and clicking Install. And it will then let you connect to Ibex. How do you connect to Ibex? Very easily. I just want to show you this so that you can have an idea that this is possible. So you go to Open, and instead of connecting to localhost here at the top, you select the remote host you want to use. So I want to use Ibex in this case, and failed to launch. Of course it did. So that's a very bad error message, but the reason it's going to fail to launch in this case is you have to run the same version of VisIt on your laptop as you run on Ibex. So I've opened the wrong version. That was my fault. I need to open the version that is sitting in my downloads directory. And so that is going to be VisIt version 3.3.3 right now. Then on the upcoming Shaheen update, we'll probably update to 3.4.1, but we haven't gotten around to those updates yet. So in VisIt 3.3.3, follow the same steps. Go to KAUST Ibex, and now I'm on Ibex. I have passwordless SSH set up, so this all happened in the background. I didn't have to type in my password or anything. And so I can go to my Scratch directory on Ibex, see if any interesting data is there. There's a Gray Scott file. We can open that, and now this will launch a job on Ibex. So until you decide what you're going to do, it's not going to launch a job. But we'll go ahead and launch a job. So it's going to create a job, run it on Ibex, and then connect back to our local computer. And it already did. And this is the other reason I like the engine. Now you can see that our engine is working, and it's on Ibex. We have one node with 8 processors. So I can just do a quick pseudo-color review just to show that it works, and we're loading, rendering this data all on Ibex. Nothing's being transferred to my local computer except the data to do this display. So it'll either send back an image or a small, very tiny data set to do this rendering on your local screen. So that's going to cover everything for us on this workshop today. I want to thank everybody for attending. This was very fun. If you have any other questions, any collaborations you want to do with us here at the VisLab, please reach out. We're here to help. So thank you.